Yeah, good morning, everyone. Very happy to have the opportunity to speak to all of you regarding a topic that is great importance for all of us. In an abstract version, it's about future of software engineering. This is not a really good title. It's more about specification engineering, which appears to be key for what comes next to all of us and will shape the next couple of years in all of our organizations. Years ago, I thought, well, in software engineering, I'm a professor in software engineering, I'm also a mathematician, so I always stay in both worlds, in the world of the pure mathematics, it's clean, pure, wonderful, formalized. And in software engineering, where real people work all day long and then they produce something that should become reliable software with various degrees of success in general. And so both worlds always appear to be quite different. Yeah? And I assumed years ago that things are step by step getting better. Programming languages, for example, they are almost in a phase of stagnation. So we do not expect any more fantastically better programming languages. Not even frameworks. Yeah, frameworks, yes, you can use better frameworks. Co-pilots have been the latest wave that reshaped development departments. But basically, I assumed that this is how future looks like, and now it's completely different. To spoil a little bit the results of my current insights, specification becomes important, and therefore mathematics. Yeah? So good news. Yeah. I hope to be able to. So let's have a look at software engineering. Just looking around. Okay, maybe I'm one of the dinosaurs that. Not 50s, yeah, okay, yeah, but starting in the 80s, 90s, yeah, we are used to this portfolio of techniques, yeah. We are used to select, to think about the right programming language, right models, used to develop our systems. We tend to make big thoughts about architecture, reshaping architectures, abstractions, application programming interfaces, for example. And years ago, it was key question which methodology to use, and people started to discuss which is a better one. We assign specialized roles today. If you have a big team, 500 people, you have a clear schema for all of that. And quality assurance, a nightmare, as we all know, and every day changing the tooling and infrastructure used to develop a system. So this is, you all know that, but there's one key characteristic. They all have one thing in common. It's made by humans for humans. All the human capabilities and limitations are reflected in all these categories. For example, programming languages are shaped toward what a typical human can process cognitively. And we are not used to have a nesting level of 20 or to have a module with 100,000 lines of code. This is beyond the practical borders of what human team members could do. But it's not by nature that a 100,000 line module is bad or worse than a smaller one. It's just because we are humans, and with our cognition, typical cognition, there might be some exceptions, but even if you consider exceptions, they are not too far away from the mean value. Yeah? But all this was done for humans, and of course to kind of civilization, yeah, here, to bring civilization to developer teams, yeah, and to guide them, to control them, but everything was made for humans. And this is what is going to change. We already saw and know these tendencies. For example, automation is not new. Yeah? Automation was always a big goal. Look at complex building processes that take place especially in the deployment phase. If you use model-driven approaches, you let generate certain parts by generators. Many of you use domain-specific language, and of course we do a lot of verification stuff. But what is really new is that machines, to be more precise, specialized or large language models trained in a special way on an enormous amount of software systems. Yeah, this is what is meant by machines. I use it as a shortcut. Yeah, this is to be clarified later. Machines now can not only read, they can interpret. That's key, yeah, interpret. They can interpret not only the formal stuff, but also the semi-formal stuff and even informal documents. So this is completely new. And what's also completely new from a technology perspective is that they can reasonably, I will talk about this in more detail, synthesize systems, system components, system structures, and even better, they can interactively modify existing systems so they can act as a developer team. They even copy a little bit the roles that we have defined for humans, although these roles might be not necessary in the long run. It might not even be necessary in the long run to use our fantastic abstraction in programming languages, because programming languages are made by humans, for humans, but machines don't need them. They will most likely invent their own programming language, which will look bizarre to us. Yeah? Sometimes they invent, even right now, their own shortcutting programming languages. So the implication, software engineering undergoes a tremendous shift from a human-centered process to a hybrid human-machine process. That's humans are in the loop, of course, because who goes to the prison? You can not even penalize a machine by telling the machine that's not going to have more energy. Yeah, this would not have an effect. So humans are in the loop. You are in the loop, but you have to be used, and you have to think about how is this hybrid combination best handled. Yeah, this is what I'm currently working on, because I'm fascinated. I see a lot of potential. I see a lot of trouble. Yeah, I'm not talking about implications for societies. This would be a completely topic, and it would be a nightmare to start to talk about it, because we all don't know what is really coming. Yeah, the only remark I have on this society issue here. Traditional software engineering, with its implementation-centric approach, with the humans implementing systems, they are the cornerstones. At the end, humans did it. And testing and validating code was also so important. And everything is now transformed into a more specification-centric approach. So there's one hypothesis, and it's not even a hypothesis anymore, it's just a forecast. Soon, and I will not define what soon means. yeah, maybe months or years, but not many years, soon. No one will code manually. And you will make an appointment to someone who is still coding manually because you have to talk to him or her. Yeah, this would be not anymore tolerated. This is a big shift also from a psychological point of view, because your long-time employees that define their ego by being a tough software engineering person, they need help, possibly, yeah, to do this big step forward, because machines generate system implementations much better. Point dot. It's a fact. Yeah, I will show you one example. And verification becomes maybe a key issue. So you will possibly spend, and you can reuse the personnel by assigning different tasks, because verification becomes absolutely critical. So verification, under verification, I summarize everything that ensures quality of the product, of the final product. So my hypothesis is, academically speaking, that software engineering transforms into specification engineering. I did a test by myself. I show you just an example. 12 days ago, for 7 days, I developed this application. It's a full application. It has import, export, serialization, a user interface. It's a very nerdy application. It's about an exploration technique for high-dimensional feature spaces for mathematicians. And no one would typically understand why this, or why you develop such a tool unless you are in mathematics. But it's a niche, yeah. It's a nice application. A good thing is this application is so nerdy that you can't argue this is a standard application, yeah. It's a very, very specialized thing, yeah. It's based on. I'll show you this. These are 857 modules of the Django toolkit. And I have a magnet here, heavily changed, less changed. These magnets summarize GitHub meta information. And I have big and small modules. And what you see is that they naturally form clusters. The color is the churn rate. These are changed more than the blue ones. Blue, cool, yeah. Red, a lot of developers are working on these modules. And now the question was how to position these particles given a magnetic field, and you need physically based iterative annealing processes. And I came up with 2 physics processes, models, and I developed during my 7 days project even a third one, which turned out to be the best one. Here you have it. Yes, it's a force-driven, barycentric, and physically based. And I will not talk about these details because this would be wonderful, but I think I would annoy you very much. Okay, but what's the key question? I use WebGL as graphics engine. I have an ordinary user interface that is completely functional, no errors in the user interface. It's state sensitive, so it depends on the physics process whether some parts are active in the user interfaces or not. It can serialize everything, and even worse, it can serialize everything into an ordinary CSV table. Why? Because tables are lingua franca in artificial intelligence, and it's so a simple format, yeah? But normally you wouldn't do it because it's unusual. But so I developed this application similar to a project a PhD candidate did 5 years ago, and he failed, yeah, after almost 2 years. So I just restarted the idea of developing the app. So this app represents in my estimation, and it's a good estimation, I think, 18 person month development time, possibly more. There are 18 as a minimum, 18 developer months. I did this within 7 days, and I did even work in my garden during these 7 days. Winter time was over. So, how did I do it? Codex. Yeah, I've heard of it. Codex. With Codex, I co-developed as a theory, writing an ordinary mathematics paper about the processes. Overleaf is using LaTeX. Yeah, this is a system which is used if you want to express formalizations quite well. Yeah, because LaTeX contains a meta information in your document. It's not words. That's a key difference. So whenever you can whenever you can choose, use LaTeX because it has a meta information, which is it's a perfect food for large language models. This cannot be compared to Word. Yeah. So I developed a scientific paper, now 20 pages long, and I mixed Codex and the paper. So I got an application that one-to-one reflects my theory in the paper, and I did not change, not a single line. How many lines? 49,000 something. Almost 50,000 lines of code. 50,000 lines of code. 7 days and doing garden work, yeah. I more or less, I had an eye, and I still have the idea how this should be programmed. So I could, of course, look behind the scenery, and it turns out it was made in a perfect way. In a perfect way. Sometimes even I was a little bit ashamed because I thought, oh, well, this idea is really new and it's better than mine. Yeah? Because I checked line by line, module by module, yeah? Because I wanted to know how good is Codex, yeah? In my nerdy field. Yeah? So I go back. I try to go back. Can I go back? It's only, yeah. Just missed the button. Okay, yeah. So 7 days, 75% of my daytime. Oh, yeah. HTML, JavaScript, WebGL, efficient use of WebGL, taking advantage of all the low-level RP features of WebGL. So this is also a certain level, yeah, of expertise you need if you want to do it this way. Outcome, 50,000 lines, roughly, lines of code, complete interactive system, and it integrated even an automated testing suite. So I run 48 tests whenever I do something critical. It also generated by itself a test data generator that stresses the system. Yeah. So normally you wouldn't do this to this level. Yeah, you would stay below. You would say, well, let's assume we have good data. Or let's assume that our test data is sufficient. But normally, typical developers wouldn't work to such a wouldn't work out these details. Yeah. So this is what I did in the last days, and now what's the essence? What's the insight? If you develop, for example, a more theoretical or formalized specification, you can map the specification to your implementation directly, step by step, piece by piece, like giving food to Codex. Yeah, it's get tested and evaluated, and then you start the next iteration. Sometimes you go back a step. So it's like instructing a developer team. Sometimes you have to correct the direction sharply. You say, no, this is not the way we would like to go forward with. That is, you have to be in control. You have to be conscious about what is your goal and how to build it. Yeah, it's not possible that someone that who knows nothing about the context would be able to do this. Yeah, so we have to be honest here. It's not a magic machine. Yeah, it's an instrument for specialists, and the more specialist you are, the better the outcomes. And it's critical that you know how to specify. If you are not good at linguistics, you will definitely have poor results. So if you are not able to formalize, because this is key for LLMs, say just do what you tell them. Yeah, say take it literally. And that's also a danger. Yeah, if you have a colleague and you know whatever I tell him, he will do it. This is dangerous. Yeah. So the linguistic precision is or has the greatest impact on the quality of results. And you have to do it in an evolutionary way. This was also the key insight. I would never be, I'm not able to specify the full system at once. So and it would be even dangerous, because then it would be hard to correct errors. So especially in the initial phase, if you start a new module, you have to take very small steps to see that your context, also specifications you did so far as context, that your context evolves in the right way. For that reason, you should never start with a big specification. This is very likely to fail. So the evolutionary principle seems to be very effective for codecs or tools like codecs. You can also choose other ones. Very short cycles provide best feedback. And so what can we learn? We have some core activities here that are emerging. We will have to do much more specification, and we have to control the generation. To be honest, I don't know how exactly to control the generation, because it's so new. Yeah, we will know this in a few years. There will be many books about this topic. But at the moment, we don't know much about how to control generation and verification and testing. This is maybe a more common field, which already has a lot of knowledge we can directly integrate and apply. Testing becomes central. So imagine if you, for example, this was when I decided to clean one of the paths in front of my home. I said, well, I have to stop at this moment. Yeah, let's pause for a moment. But while we pause, you do a refactoring. Sort out the rendering logic from the physically based simulation logic, from the UI logic, from the data logic, from the serialization logic. It's a good task for a team. They might be not so happy if they listen to the new order you gave. But it was okay for codecs, yeah, for me, because I had some time left, yeah, and well, I knew that it's doing good work, yeah, and it was an extremely long thinking time, by the way, yeah, agent-based, yeah, and nice result. It was perfectly separated later on. Yeah, something that would have caused a lot of trouble in a typical team, because who would do this? Let's say ordinary work. This work that is not really creative. Yeah, it's a lot of work. And you can do this. So also what triggers my interest, and this is something we might discuss today later on, is imagine if you have many codecs instances and you have many people like me in your team, and if they say, they give great instructions, perfect instructions. And they even write papers, so I'll say, instruct the system. They should write papers, yeah? It's a good measure, by the way, a good methodology, yeah? That you ask people that they formalize what they do. Normally you wouldn't ask for formalization, you ask for coding stuff, yeah? You say, do it, implement this, yeah? But now this is changing. But what triggers my interest was, how did evolve the system? How does it evolve, yeah? So we will have to have tools that allow us to monitor the actual outcome of the thinking processes. For example, at the moment I'm working on a mapping of thinking time to modules. So a key metric will be how many seconds of thought, of thinking, went into a module. Yeah, still I don't know what to do with this information, but it will be interesting to see how thinking intensive are modules, how you spend energy on your modules. You don't spend any more people. Yeah, you spend people that instruct the machine to work on the source code. So we need a transparency for the system evolution, how to monitor all these generated artifacts. There might be a small prompt that leads to tremendous changes. So it's not anymore one-to-one mapping or a linear relationship. Yeah? That's different to what we do so far. We need explainable generation processes. So why have things changed? And especially if architecture changes, we want to ask, or we have to be able to ask for why and how, which prompt was responsible for that. And of course, we have to detect deviations from expected behavior. Expected behavior might be the right behavior, or might be just a behavior you considered so far to be the right one, but it might change. Yeah? So expected is no evaluation. Yeah? Expected is simply what you know about the behavior. And especially we ask for the situation, or we ask to detect situation where human intervention, especially, let's say, from the team lead, from any other specialized person in your development process, needs to make an intervention. Yeah, there's one obvious tendency. It's called proliferation, Wucherung. Source code might explode just because someone specified something that, in consequence, leads to an explosion of source code. And this is typically not what you really want. Yeah, at least you have to think twice about your specification. But you wouldn't see this anymore because no one would complain about having too much work. Yeah. If codex works for, let's say, 10 seconds or 30 seconds, you will not realize. Yeah? So the proliferation, for example, becomes a phenomenon that has to be traced. And for human control, for the human in the loop, it's needed that we have transparency and explainability. And I think Hans will talk about this. And Oliver, I'm almost done. A change of mindset. So software engineering definitely is in a new phase. Yeah? And once again, I tell you, soon you will ask people not to code manually. And it will be even penalized, or these employees have to stay in front of the others and have to explain why they did this. Anachronistic behavior. Humans as programmers disappear. Human as system specifiers and supervisors appear. And machines implement and especially evolve software systems. That's key. Yeah? Generation is, in the past, it was always a one-time activity, but now the evolution is much more difficult, of course. The evolution will be key for these tools, and that we use these tools to evolve software systems. But in the central insight is that everything depends on specifications. So specification engineering, by the way, also in the Hasso-Plattner Institute, there's a new thought about new studies we will offer soon, hopefully, will be about specification engineering, complex systems engineering that completely turns around the traditional computer science, because for software engineers, different capabilities are required in the future. So this ends my talk. Thank you very much. Any questions? Oliver, I would like to answer questions if there are one. Yeah?
I'm a bit afraid that there will be questions because we're not ahead of time, but Jürgen Döllner will be around for a while.
Thank you. It was very interesting. Thank you. I have two questions. First question is the model you showed. Does the system verify itself? Because usually I know you need like a cross-validation. So there should be an independent system which is checking what the code wrote. How was it in your case? And then I would have a second question.
Okay, testing was not the core part of my work during these 7 days. However, I realized that's important, so I asked the codex and I gave him the specifications to use different approaches for testing. Yeah. For example, in a physical-based simulation, if you know the results of a simulation process for a given data set, you can do sharp testing. Yeah? These are the results that must be reached. Otherwise, we have a problem. Yeah? On the other hand, I also did a testing built-in that asks for servant JavaScript constructs. So more coding related test. I also instructed the system to avoid certain API calls in WebGL because I don't like them. Yeah, because I know that they cause troubles in some process. Yeah, so it was a hybrid approach. And your second question, please.
In university, I learned software patterns. Are they obsolete now?
Software patterns are.
Is it also made for human reading? Because you said code for people, from people, for people.
Yeah, software patterns. Software smells even, yeah. But software patterns, yeah, let's go for software patterns first. Software patterns are maybe the most prominent example of a romantic view on software. Yeah? And we like them because we can talk about, yeah, it's almost like they are just good narratives. Yeah, software patterns in practice at a certain moment it was great for the insight. However, it turns out that real developers in real projects, if asked for software patterns, they tend to show opportunistic behavior and to work along these software patterns, sometimes even if it doesn't make sense. For a machine, it's not important because you will not intervene and change something in the pattern usage because you're not interested in. There's maybe a nice analogy. How many times do you correct the PostScript code when you print a document? Yeah? Who looks in the PostScript? We believe that our text processing systems produce correct PostScript. I still remember one colleague that tended to correct the PostScript for reasons I never understood. Yeah, but it was interesting. Yeah, but basically senseless. Yeah, so many aspects of software engineering made for humans become senseless. Possibly the patterns, unless we talk about software architectures. At a high level, software architecture should be under control of the human. Because this is your strategy in your enterprise. You want to divide your big system into certain subsystems, and this is just for strategic reasons, for economy reasons, for business reasons, for legal reasons even. Yeah, and what also should be under your control are RPs. Otherwise, you lose the ability to replace a certain component. So I see the human in the loop is not in the software pattern world, but more in the architecture and RP world.
Thank you very much, Jürgen Döllner.